Welcome to the presentation on the Terra site Sustainable Construction Monitoring Drone, designed to support sustainable project delivery. This initiative integrates environmental, social, and financial sustainability by reducing carbon output, promoting inclusive engagement, and ensuring resource efficient planning. The project adopts a digital-first approach to minimize paper use and streamline collaboration. For this process demonstrations, I am using MS Project because it allows clear workflow, sequencing, milestone tracking, and resource allocation. It also supports sustainability integration by enabling dashboards for carbon indicators, risk registers, and stakeholders coordination throughout the full life cycles of the project. This next slide outlines the core ESF objectives that guide the TerraSite PMO project. Environmentally, the aim is to reduce emissions by adopting digital-first operations, energy-efficient hardware, and circular procurement practices. Socially, the project promotes inclusive collaboration by ensuring all tools and processes are accessible and support transparent engagement. Financially, to focus on long-term cost control through smarter resources allocations and lifecycle planning. The key deliverables including the prototype ESF tracking software modules, the testing framework, and sustainable procurement plan all are directly aligned with the project scope and environmental needs identified in the process map. In phase first, the project begins by defining the full scope and identify the environmental needs that shape all later decisions. Stakeholders such as the PMO team, sustainability officers, digital analysts, and suppliers are mapped early to support transparent collaboration. The requirement analysis loop ensures all function and ESF requirements are reviewed and approved before moving forward. Sustainability is embedded directly into the approval gate, meaning the project cannot advance unless circular procurement, digital efficiency, and low emission criteria are validated. Risk identifications starts here, highlighting the potential gaps in resources, compliance challenges as stakeholders, misalignments at the earliest stage. Phase second focus on translating requirements into a functional drone-based monitoring um, solution. The system's architecture is designed by selecting sustainable hardware such as low energy sensors, modular components, and recyclable materials. Software modules are mapped out data analytics, anomaly detection, and automated compliance reporting. Technical dependence such as synchronizations between sensors, software modules, and RTK GPS are assessed by ensure seamless integration. Circular design principles are embedded through energy-efficient components, life cycle conscious material choices, and flight path optimization to reduce emissions and operations waste. Phase 3 involves transforming the solution design into working prototype. This trains manufacturing the drone using lightweight, low emissions materials and assembles the energy efficient sensor suite. In parallel, the developers create and integrate software modules, including the monitoring, analytics engine, and complex dashboards. Key milestones include completing the physical prototype and achieving the full hardware software integration. ESF prioritize remains central, particularly through sustainable material choices and fair labor procurement. Risks such as technical integrations issues and supply chains delays are managed with fallback suppliers, stage testing, and component redundancy. Phase 4 focus on validating the prototype through structure testing and debugging. The team performs functional tests, environmental monitoring, accuracy checks, and performance assessment to ensure the drone and software operate reliably. A clear QA workflow is followed, with each defect triggering a debug test cycle until all requirements are satisfied. Project acceptance depends on meeting safety standards, environmental compliance metrics, stakeholders' expectation, and system reliability benchmarks before the projects can progress to deployment. In phase 5, focus on refining and fully integrating the drone system following initial testing. This includes calibrating sensors for higher accuracy, optimizing flight paths and energy consumptions, and adjusting software modules to improve detection and reporting performance. Stakeholders' feedbacks, particularly from testers and sustainability teams, incorporated it to enhance usability and environmental impact. Risk and points are applied to manage issues such as calibration drift, hardware stress, and software inconsistency. The phase also emphasizes lifecycle optimizations, ensuring the system is durable, energy efficient, and easy to maintain, supporting long-term sustainability and reducing environmental footprint throughout operational use. This slide summarizes how sustainability is integrated throughout the entire project lifecycle. Circular procurement ensures all materials and components are responsibly sourced, reusable, and recyclable. A digital-first approach reduces paper usage, lower operational emissions, and improved efficiency through workflows and virtual testing. Carbon footprint reduction is made through low energy design choices, efficient flight operations, and sustainable testing practices. Financial sustainability is monitored to multiply checkpoints, ensuring the project remains cost effective while supporting long term ESF commitments and delivering value beyond the prototype stage. This slides highlighted how digital tools such as Trello, Asana, or MS Project support the Carbon Light PMO workflow. Dashboards visualize key metrics including um, progress, resource consumptions, and carbon emissions, ensuring ASF visibility at every stage. Milestones are tracked through interactive timelines that map the transitions from design to prototyping, testing, and refinement. Risks registers enable automated alerts for delays, non-compliance, or technical issues. These digital features actively support sustainability too by enabling real-time carbon tracking, verifying responsible procurement, and ensuring ASF alignment throughout the project lifecycle. At the end, in conclusion, the process map provided a structured roadmap from project initiation through refinement, ensuring clarity and sequencing and resource alignment. Using the digital project management tool, enhance transparency, collaboration, and sustainability tracking throughout the workflow. This project strengthened core professional skills, including modeling complex workflows, embedding sustainability principles in the decision making, and coordinating diverse stakeholders. Ultimately, the integration of environmental, social, and financial objectives contributed significantly to the overall success of the TerraSite PMO, ensuring that the final solution is not only technically robust but also sustainable, inclusive, and economically viable across its life cycle. And the next slide says Francis, and thank you.